Okay, the next one will be the series parallel connected DC circuit. Series parallel circuit. Series parallel circuit. So there are two situations. I give you the two examples. Resistor R1 is connected here, and they are parallel branch. Resistor R2 and resistor R3. They are connected parallel. So if we connect this way, we have to find out the total resistance RT. So in this case, you have to solve the parallel branch. Firstly, because the R2 and R3s are connected in parallel. Therefore, totals are resistance R23. R23 means is a R2 and R3s are connected in parallel. R2, 1 by R23 equal to 1 by R2 plus 1 by R3. So firstly, we connect the parallel branch. Resistor R1, R2, R3. So here R2 and R3s are connected in parallel. Then they are connected in series with the resistor R1. So in this case, firstly we saw the parallel connected resistor. R2 and R3s are connected in parallel. Therefore, 1 by R23 equal to 1 by R2 plus 1 by R3. Therefore, in this case, R23 can be calculated 1 divided by 1 by R2 plus 1 by R3. So this is the way firstly we calculate. Then we calculate the total resistance RT. R total equal to R1 plus R23. Therefore, the R1 value and R23 is 1 divided by 1 by R2 plus 1 by R3. Then you substitute that R2, R3 value, then we calculate the total resistance RT. So this is the first situation. And second one is, this is you see the resistor. Resistor R1 is here, and resistor R2 and resistor R3 are connected in series. So this connection. In this connection, R2 and R3 are in series connection, then their combination is connected in parallel with the R1. So in this case, we also firstly calculate the R2 and R3 combination. R2 and R3 combination is R23. R2 and R3s are connected in series. Therefore, R23 equal to R2 plus R3. So this is the way we got. Then R23 is connected in parallel with the R1. Therefore, the R total can be calculated 1 by R total equal to 1 by R1 plus 1 by R23. Because of the R1 and R23 are connected in parallel. Therefore, 1 by RT equal to 1 by R1 plus 1 by R23. So in this case, R total can be calculated 1 divided by 1 by R1 plus 1 by R23. Then we substitute the R23 value 1 divided by 1 by R1 plus R23 is R2 plus R3. So this is the way we calculate the voltage. And then if the supply voltage is a V, in this case here supply voltage V, so the voltage draw across the R1 is V1. Total current is IT. The current flowing to R2 is I2, the current flowing I3 is R3. So this saturation. So the first saturation, this is a R1 here, supply voltage is a V. To the current flow is a I total. Then current flow into R2 is a I2. The current flow into I3 is a R3. The voltage drop across a R1 is a V1. Voltage drop across a R2 and R3 is V23. So that in this case, we write down the equation. V equal to V1 plus V23. I total equal to I2 plus I3. So this is the way we calculate the voltage of current. So that in this case, you see the R1 and R23 parallel combination. So to the supply voltage V, if the voltage drop across a R1 is a V1, voltage drop across a R2 is a V23. So in this case, V1 plus V23 is equal to supply voltage V. So the current IT equal to I2 plus I3. So this is also, we calculate the voltage and current in the series parallel branch. Then based on this principle, we solve those problems. First condition, this is a problem here. Resistor R1 120 ohm. Resistor R1 120 ohm and R2 is 150, R3 is at 220. So resistor R2 150 ohm. Resistor R3 is 220 ohm. Then this is a connection. We connect the both resistor to the supply voltage 100 volt. To the supply voltage 100 volt, R2 150 ohm and R3 220 ohm, they are connected in parallel. Then connected in series with the R1 120 ohm, and we connect to supply voltage 100 volt. We need to calculate equivalent resistance. We need to calculate the total current. We need to calculate the voltage drop across the R1. We need to calculate the voltage drop across the R2 and R3. We need to calculate the current in R2 and also current in R3. Those need to be calculated and also need to calculate the power total. Those has to be calculated. So the resistor R2 150 ohm, R3 220 ohm, they are connected in parallel and connected in series with the R1 and connected with supply voltage 100 volt. We have to calculate total equivalent resistance. We need to calculate the supply current to the supply current IT. We need to calculate the voltage drop across the R2 and R3 V23. We need to calculate voltage drop across the R1 V1 and current in the resistor R2 and current in resistor R3 as well as the total dissipated power. All things have to be calculated. So firstly, we write down the equation for the equivalent. In this case, R2 and R3 are connected in parallel. Therefore, the 1 by R23 equal to 1 by R2 plus 1 by R3. We write down this equation. Therefore, the R23 equal to 1 divided by 1 by R2 plus 1 by R3. Then we substitute the value. R23 equal to 1 divided by 1 by R2 is 1 by 220. 1 by R3 is 1 by R2 is 1 by 150. 1 by R3 is 1 by 220. So 1 divided by 1 by 150. So 150, 1 divided by 150 we got. So the 6.66 into 10 power minus 3. Plus 1 divided by 220. 4.545 into 10 power minus 3. So therefore, this one we got is 1 divided by 6.66 plus 4.545 into 10 power minus 3. So this 10 power minus 3 goes to the numerator, that will be 10 power 3 divided by 6.66 plus 4.545. 6.66 plus 4.545. So you got 11 by 2. 11.205. So the 10 power 3 is 1000. 1000 divided by 11.205. You got is 89.24. So this is the so this will be the 1000 divided by 11.205. So 89.24. This is for the R23. Then we calculate R total. Because of that, this R23 and R1 are connected in series. R total equal to R1 plus R23. So R1 is 120, R23 is 89.24. So we add the 120 plus 89.24, you got the 2019, 209.240. So this is for the total resistance we calculated. And also need to calculate a circuit current. So that we got the total voltage 100 volt, total resistance 209.24. Then we can calculate the current. So I total equal to V divided by R total. So voltage is 100, resistance is 209.24. 100 divided by 209.24. So 100 divided by 209. So you got there 0.478 ampere. So total current is 0.478 ampere. Then we can calculate the voltage drop across the R1. So because of the total current passing through the resistor R1, so the V1 can be calculated. Total current IT multiply resistor R1. Because of the total current also passing through the resistor R1. IT multiply R1. So IT is 0.478. R1 value 120. 0.478 multiply 120. So we got 57.35 volt. So 57.35 volt is total voltage. We also need to calculate the voltage drop across the R2 and R3. So in this case, we can calculate by two ways. Because of the total voltage VT equal to V1 plus V23. So in this case, VT value is 100, V1 is 57.35, then we calculate the V23. So in this case, V23 equal to 100 minus 57.35. So 100 minus 57.35, you got the 42.64 volt. This is one method. Alternatively, total current ID flow into the R2 and R3 combination. Therefore, the V23 is also equal to I total multiply R23. So I total is we know about the I total. Total current I is 0.478. V23 we ought R23 is 89.24. 0.478 multiply 89.24. So the 0.478 multiply 89.24. This is also 42.65. We calculate that two ways. All are correct answer. All those are slightly different. If you know that to the voltage VD equal to V1 plus V23, because of the this R23 and R1 are connected in series, therefore the voltage total equal to V1 plus V23. So in this case, we have already calculated V1, we know the VT, and we calculate the V23. Alternatively, total current flowing into the parallel combination of the R23. Therefore, the V23 equal to I total multiplied by R23. In this case, we substitute the I total value, R23 value, we got the voltage. So we can calculate by two ways. Both are the correct answers. So this is the way we calculate the voltage drop across with R2 and R3 is 42.64 volt. This we got. Then we calculate the current resistor R2. I2 equal to, because of the voltage is across here, V23 across and divided by the resistor R2, we can calculate the current. So I2 equal to V23 divided by R2. So V23 is what you call the V23 is 42.64. R2 value is 150. 42.64 divided by 150. So you got 42.64 divided by 150. So that will be the 0.284 ampere. I2 we calculate. And also we calculate the I3. V23 divided by R3. So V23 is a 42.64. Resistance is 220. 42.64 divided by 220. So 0.193 ampere. This is the way we calculate it. And then we also need to calculate total power, P total. P total is voltage total multiply current total. PT equal to VT multiply IT. VT is 100 volt. Total current is 0.478. So that will be 47.81. So this is the way we calculate it. So this problem, in this case, R2 and R3 connected in parallel. So that we combine the R2 and R3. So R23 equal to 1 divided by 1 by R2 plus 1 by R3. Then this R23 and the R1 are connected in series. So that we calculate R2 equal to R1 plus R23. This is the way we calculate. And also current IT equal to V divided by RT. And also that we can also calculate the voltage drop across the R1, ID multiplied by R1. And then we also calculate the V23. V23 is a VT minus V1 or ID multiplied R23. And then if you know the V23, you can calculate the I2 and I3, voltage divided by resistance R2 or voltage divided by resistance R3. Total power equal to V total multiplied by I total. So this is the way we calculate this problem.